It is March 16th, Sunday afternoon. Headed into work for a few hours, try and hit the gym, and I wanted to do a brain dump on my drive into Oakdale. This is Landon Blake, ruggedly handsome land surveying extraordinaire. In this truck brain dump, we are going to talk about annotations and how they're handled differently in CAD and GIS. I'm doing this video mostly for Cosette. So she's been doing a little more now in QGIS or Quantum GIS, which is the desktop GIS software that we use at our team at Redefined Horizons at RH. And I noticed as she was working that she was trying to manipulate some annotations like she would in CAD. And I had to tell her, that isn't going to work because we're in a GIS program, not a CAD program. And it's not her fault. That's actually a very natural thing for her to do. She's only been with us 5 or 6 months, and she's primarily been working in CAD. So I thought that this would be a good topic for not just for Cosette, but for my other members of my team, and we'll share it on YouTube. Before we dive into the meat of the brain dump, which is going to be the 3 key differences between how annotations are handled in CAD and GIS, I want to just give some definitions so we can make sure that we're talking about the same things. So when I say annotations, what am I talking about? I use that term annotations as a broad term to refer to what we would call in CAD single line text, multi-line text, leaders, dimensions, and labels. So it's a broad basket that encompasses all of that. So those are all different types of drawing entities in CAD that have some text component to them. Could be a measurement or a simple label. One of the things you learn early on as a CAD drafter at RH is how to work with annotations in a CAD drawing. It's how to label road names and put descriptions on property corner monuments and create parcel labels with owner names, APNs, addresses, area, that kind of thing. Label lines with distances and record references and bearings. We do a lot with annotations. We create point tables, line tables, another type of annotation in CAD. When I talk about annotations in this brain dump, I'm referring to any kind of entity in your CAD or GIS software that is basically presenting information to the user with letters, numbers, and symbols, essentially, some kind of text-based content. What type of CAD am I talking about? I realized I needed to clarify this when I tried to get some information on this topic out of, I can't remember if it was Gemini or Claude. I think it was Gemini. And most of the information that Google Gemini came up with on this topic was based on a comparison of GIS and CAD as it's used for basically 3D modeling and mechanical purposes. And we do a very different type of CAD at RH. So we don't label in 3D solids and dimensioning parts like a mechanical engineer or a structural engineer would be. So we do 2D CAD. We don't really do 3D CAD per se. We do what we call 2.5D CAD. So we do work with contours and surfaces and things like that, but we're definitely not working with 3D solids. If we need to do that kind of 3D modeling at my shop, we would use a tool like SketchUp. I'm talking about 2D drawings, primarily for mapping purposes. That's the kind of CAD I'm talking about. So it's AutoCAD Lite, or we like to use BricsCAD at my shop. We have BricsCAD Pro, but we're not doing 3D solid modeling in that tool. We're doing mostly 2D or 2.5D Drafting, we also use Carlson Survey. That's another tool. So that's the kind of CAD I'm talking. Is what are the three key differences between the way annotations are handled in 2D CAD for mapping applications and a GIS software like QGIS or like ArcGIS? I'm going to give you three differences. There could be more. Those three differences are the source of the content for the annotation, the format and the style of the annotation, and the way the annotation is positioned on the map, or in CAD, what we would call model space. I'm going to drill down on all three of those a little bit. Now let's drill down on those three key differences. So the first one was the content source. So in CAD, most frequently, the content of the annotation is being directly input by the user. Now, there are some instances where the content of the annotation is taken directly out of, is based directly off the property of a drawing object. So an example would be a dimension of length or dimension of an angle. But that's typically a small proportion of the text in our drawings. I don't know, might be 25%. The rest of our text, a ton of our text is going to be user entered. So we're entering information that we've taken from title reports or from our boundary resolution or from our control survey, or we're labeling features off of a UAV aerial photo. So there's some human input there that's creating the source of the content. And even when the content is based on the property of an entity or an object in the drawing, like the length of a line or the angle between two lines, depending on how those annotations are made in the CAD software, a lot of times those values are not dynamic. In other words, they don't change as the drawing entity changes. So a good example of this is the line labels that we create using Carlson. We create, for example, we label the bearing and distance of a line, and then we go in and customize that text as a human being. We make edits to it. We give it an identifier, and then we might add, maybe that's a measured line between two monuments. So we'll add a suffix to indicate what the measured length is, and then we might show one or two record lengths, and then we might put crow's feet on the end of the text label. So there's some customization of that, and because we're customizing the content of the annotation like that, we typically don't want it to change. We don't want it to be dynamic. Even if somebody trims or moves the line a little bit for graphical reasons, we don't want that data in the annotation to change. We want it to stay fixed. You have some control over that as the CAD user. Usually there's some toggles and settings, and you can tell your CAD software, I want this value in the annotation to update as the property of this connected drawing entity updates. But that's not how we work most of the time at our age. Most of the time when we're in CAD, we want to do some kind of customization or override on the annotation. And we don't want that to change, even if underlying drawing entities change to have minor changes. Okay, GIS, we essentially have the opposite. Almost all of the annotations in a GIS are going to be based on the properties or attribute of a feature in the map. And it is much more difficult to customize and create free-form, tailored annotations. As an example, in a GIS, you might label the name of all the roads on a road layer. The value of that label is going to be taken from an attribute, like a road name attribute in the data layer, in the table for the roads layer. And you're not going to typically go in and individually customize and position all those labels. Now, you might do something like add a suffix or a prefix. You might be able to do some rules-based customization of that labeling, but most of it is going to be computer automated. It's not going to require individual input from the user on every label. So there's a pretty significant difference there in the content source of annotations between CAD and GIS. CAD, usually some human interaction there to customize or tweak the label content. GIS, very much more automated and built for automated systems. Okay, that second difference I mentioned is the formatting and style of the label. On a program like BricsCAD, that is going to be controlled by things like your dimension style and your text style that you've selected for a particular text entity. And you even have the ability to go in, like with multi-line text, you can have segments that are bold or italics. You can change your paragraph indent and your line spacing and your paragraph spacing, just like you could in a text editor like Word, Microsoft Word. Very fine level of detail and control on the individual annotations. There is some ability to control that as groups via text styles and dimension styles, but you can also go in and do individual overrides on an individual annotation, a block of text, for example, and not so much constrained by the layer that the drawing entity is on. For example, you could have two dimensions on the same dimension layer in your CAD drawing, but they use different dimension styles and look very different, even though they're on the same layer. Again, GIS, very much the opposite of that, typically. The format and style of the annotation in your GIS is those properties of the annotation, the content and the format and the style are going to be very much driven by the properties of the layer that contains the label or the annotation. So it's very much layer based and layer controlled, and you have less control to customize individual annotations, the appearance of individual annotations, or to have annotations with different styles on the same layer as a general rule. Third thing we mentioned, the third key difference was the way annotations are positioned on the map. In CAD, that is very user driven. So users are placing individual annotations typically. Not a lot of automation. There is a little bit of automation. So for example, when we're creating bearing and distance labels in Carlson, we can set up some very simple rules about where the label should be placed. Or when we're doing point labels or labeling points, we have some ability to control the positioning of the elements of the point label, like the point number, the elevation, the description, for example. But much more user driven. And a good CAD drawing typically involves a lot of user interaction to get the labeling right, to avoid things like overlapping labels. GIS, in contrast, the positioning is very much more automated, out of the box, and rules based. Set up rules in QGIS to avoid overlapping labels, but it's more constrained and limited, very much more rules based, and you're limited to the rules primarily that are built into the GIS software. You have less control as a user. Another example of this difference is it's really easy in a GIS software to say, I want these labels to show up only between this scale and that. Very easy to do in QGIS. Way more of a pain in the butt in something like BricsCAD or AutoCAD. You can do that a little bit and annotative text, which can have different versions for different scales, but it's a pain in the butt. It's a little bit clunky. So that's an example of the differences in the way the two softwares work. When we talk through those three key differences in a little more detail, you can see some common patterns here, right? CAD allows for much more, not only does it allow, but it depends on a lot more human interaction and human input, less automated rules based. GIS, much more automated and rules based, less opportunity for customization and human input. So which is better? You want to start a flame war on the internet, you could ask that question in a social media post. So I'm going to give you my honest opinion. There isn't an overall better way to handle annotations for mapping purposes. It's just a set of trade-offs. And that's one of the things we try and teach our folks at our age over and over again is there are no silver bullet solutions. Typically, there are only trade-offs. So there's advantages and disadvantages of each approach, right? If you want to create a map of all the roads in a county, if you want to try and go in and label all the road names in CAD, like by hand, manually, that is going to be a huge amount of time and effort. If you set up a good rules-based system in QGIS, you could literally do that in seconds. So that's the power of the automation. Now, here's where it gets a little bit tricky. If for some reason in your map, you want to customize the positioning and appearance of certain individual road labels, very easy to do that in CAD, not very easy to do that in GIS, a little more clunky. Right? So there's different trade-offs there, right? If you have fairly uniform data that can be annotated with a simple set of rules, everything can look essentially the same. All the labels on a particular layer related to a particular layer can look essentially the same without a lot of customization. GIS is going to do a great job of that. If you need to customize annotation content or have very precise positioning, or you need to customize the actual annotations that appear in a drawing, you need to add a lot of text that isn't directly related to the mapped entities, the features or the drawing entities, then CAD is going to be a better choice. It's going to excel at that, allowing you that additional control. So there's some trade-offs there. And I want my folks to just understand those trade-offs. That's part of the reason why I'm doing this brain dump. Now, I know there's going to be some people that listen to this brain dump on YouTube or that read the article I'm going to create from it, and they're going to freak out because they're going to say, oh, my CAD software does both, or my GIS software does both. Okay, so that's true. There are hybrids. So you can get CAD-like labeling functionality in your desktop GIS, or you can get automated labeling, GIS-like labeling in your CAD software, but those are hybrids and they're not typically off-the-shelf functionality. You're usually working with a plugin or an add-on or a more premium version of the software. And at some point that is being bolted on top. That additional hybrid functionality is being bolted on top of the underlying core software model. Right? There's just some fundamental differences in how CAD software and GIS software store the data about the thing that is being graphically presented or being drawn and labeled and annotated. And there's some fundamental trade-offs to that data model, underlying data model. And you can do some hacks and some other things to lessen those trade-offs, but those underlying trade-offs are still there. And that's why part of the reason why I wanted to talk about this. I think that's going to wrap it up for this brain dump. And I need to do some training videos. It'd be cool to get a training video that actually showed some of these differences. That would be cool. So let me think about that. And I'll definitely do some more training videos about annotations and GIS because my team, they all do an excellent job of annotations in CAD, but we could use some more practice in annotations in GIS. And I'll do some more brain dumps on GIS, and maybe I'll do some more brain dumps on the differences between CAD and GIS because I think that would also be interesting. I hope people find this brain dump useful. Thank you for listening.